Good afternoon, everybody, and welcome to Texas. Pictured here is the low-voltage system of a Model S from 2012. This car was primarily designed with vendor-source controllers integrated by Tesla. There are over 300 low-voltage devices that encompass everything from the mundane, like the light in the glove box, to the complicated, like the infotainment computer, to the safety-critical, like the airbags, steer-by-wire, and brake-by-wire. The low-voltage harness is built from individual wires, cut to length, crimped, and inserted into connectors, a manual process that is tedious, error-prone, and doesn't scale well. Going forward, we want to reduce the size and complexity of the harness and enable automated manufacturing.
These wire harnesses introduce extraordinary complications, especially in the early stages of development and bring up of a vehicle, because when we're trying to bring up this entire system and we see that it's not working properly, we don't know whether it's a problem with the software, with the controller, the processor, any of the endpoints in this entanglement of wires. And so we have to go and debug everything all at once. And Pete's going to tell us about how we're going to make it better.
Mm-hmm. So I'm going to talk briefly about a few things that we've changed over the years since the Model S. With the Model 3, Tesla started designing an increasing share of our controllers by merging controllers together, and we were able to simplify the design with a significant reduction in wire count and weight. Going from S to 3, we reduced the wire harness by 17 kilograms compared to Model S. And this is a pretty big deal. And just to put that into context, our VP of Engineering, Lars, will deliver a bottle of your favorite spirit to your desk if you manage to save a kilogram of weight from the car. So this improvement cost him quite a lot. Did we skip one? Yeah. The original Model 3 controllers were enhanced and then built into Model Y. Those improved controllers were then moved back into Model 3 when we introduced the heat pump. At that point, we had shared controllers across both cars, which helped simplify our supply chain. Those Model 3 and Y controller designs were then updated and enhanced for the new versions of Model S and X that we introduced in 2021. For Cybertruck, we are now designing 85% of the controllers in the car. For the next-gen platform, we're going to finish the job and be designing 100% of the controllers to give us full control of the design and the supply chain at the component level. Having full control of the supply chain at the component level has been critical to Tesla over the last few years as the supply constraints have hampered our ability to build cars.
And with that control comes control over all the software, which enables us to develop features and functionality that we never even dreamed of at the time we designed the hardware. So that's why you see software in your cars getting better and better over time in ways that we didn't even think of when we designed the hardware in the first place.
Mm-hmm. Yeah, Sentry Mode is one of my favorite last-minute changes.
One of my favorites.
With the introduction of Model 3 in 2017, we deleted relays and fuses from the car in favor of e-fuses. E-fuses replace moving parts with solid-state transistors. They provide fine-grained control of the power system to software and allow software to do advanced things like load shedding in the car under adverse conditions. E-fuses also allow for software-controlled retries for transient faults, and they allow for detailed monitoring of the power system over time.
Yeah, the theme you hear a lot about today is software-controlled hardware. And when I think about that in my team, software-controlled hardware is fundamentally about being able to sidestep what otherwise would have been static trade-offs between one attribute or another in a piece of hardware. We are able, with software, to instill intelligence, context awareness, and context-specific behavior into what otherwise would have been a piece of hardware that had to get optimized for one type of scenario. We get more of everything.
In 2022, we completed the transition from lead-acid batteries to lithium-ion batteries, and which use a new toolless connector. We expect lithium-ion batteries to last for the life of the car, so don't expect anyone to wake up to a dead battery ever again. This eliminates a major source of failures for our car. And the toolless connector makes it easier to service the car, and it also includes a software feature to allow validation that the connector has been properly installed at the end of a service event, which removes another source of failures in our cars. Obviously, the mass and volume savings are also significant, which is super helpful. At Tesla, we're always trying to improve every single component in the car, and a nice example of that is the 15-inch display that was originally shipped in the 2017 Model 3. Over time, the cost of the display has gone down 24%. We've been able to reduce the weight by 12%, and we've reduced the power by 33%. At the same time, we've increased the brightness of the display by 50% and improved the color accuracy. So this is one of our favorite things at Tesla, is to make a component cheaper and better. At Tesla, the drive to improve efficiency in the car is never ending. I think of it as like peeling a carrot. You just take a swipe at it, a little bit falls off, doesn't really make much of a difference. But if you just keep at it, over time it accumulates into a pretty significant improvement.